Okay, first of all, welcome everyone. Welcome everyone to this event. I'm really happy to having collaborated with Aiko, with kindly offered this time to talk with us. As I said, welcome everyone. I'm Francesco Alonso, and I'm a member of I'm a part of the staff of PoliMi Data Scientists. And so I will just, as I said, steal few seconds just to I am at the end of this. Okay, just a second. Okay, I will just steal few minutes to introduce what is PMDS and what we usually do as a student association. So first of all, what is PMDS? PMDS is a student association of Politecnico di Milano, which was born with the aim of basically build a sort of meeting point between the students and the companies, and the students and the researchers of the field, of the data science field. And our main aims are to basically organize events like the one you're participating right now, build a community of passionate students, and also publish from time to time data science news which are selected by us. So as regards the community, we basically, what we do, as I said, is trying to build a community of passionate students who are willing to share and exchange ideas among the members of the community. And this is one of the main aim of our association. When we talk instead about events, what we usually do is that we have basically two main batches of events. The first one is to organize events that are aimed to connect the community of students with the companies related to basically which main business is related to data science, like the one you're participating right now, as I said. And the second batch of events that we organize is related to connect the community with the researchers that operate in the data science field. When instead I talked about data science news, I meant that we periodically publish some blog posts related to machine learning techniques. And we also publish at the beginning of each month, usually, we publish a newsletter in which we include the most exciting news related to the data science field, which have been selected by us. Now, this last feature that I just mentioned is devoted only to PoliMi Data Scientist member, but let's see what being a PoliMi Data Scientist member means. Actually, we have reached an important milestone a few weeks ago, and we are now more than 100 members, and this is really an important goal for us. And I would like to thank really everyone who has made this possible. And being a PoliMi Data Scientist member means to get to receive basically for each month the monthly newsletter that I was talking that I was basically explaining before, and get access to some exclusive events which I've organized from time to time, and get access also to a job portal in which we basically publish the job offers which we think they're worth to be shared. Now, if you want to know more, clearly this was a really quick introduction about our association, because I don't want to steal really more than 5 minutes to the Aiko representatives. But again, if you really want to know more, you can go in on our website, which is PoliMiDataScientists.it, and there you will find every information that you need. And if you want to contact us, you can reach us in all the social media that you see here in this slide, which are basically Instagram, Facebook, and LinkedIn. And we also have a Telegram group in which we are basically building the community of students. So yeah, just keep in mind the website, and from there you will be able to reach us. So this was my really brief introduction. Now I will give the floor to Lorenzo, who will basically start the actual event.
Fantastic.
Okay. Okay.
Yeah, I'm here. Can you guys hear me?
Yes, we can hear you. We can hear you. I will just stop sharing so that you can share your screen.
Yeah, absolutely. So hi, everybody. Maybe, yeah, what will happen today is really a 10 minutes introduction on my part, really just explaining to you the vision we are trying to follow in Aiko and making sure that you guys understand the crazy idea that we have and how we're actually making this become a reality. And then I will leave the floor to our four outstanding engineers that you see here today, Ilaria, Dilara, Teme, and Federica. And they will present basically the technicalities of what they're doing in their daily job in Aiko. But I will let the floor to them because that will be the most interesting part probably. So let me just share the screen. Right. Are you able to see the screen?
Yes, we are.
All right. So, okay, so for those who don't know us, we're Aiko, and this is our slogan, Artificial Intelligence for a Multiplanetary Future. And really, let me give you 30 words of introduction on the company. We are a deep tech company based in Torino, Italy, at least for the moment. And our goal is to support the expansion of humanity beyond Earth with our technology. And our technology is artificial intelligence and automation software for upstream space applications. Upstream means that our technology directly goes on board satellites or space probes, spacecrafts in general, or in the mission control center. So it means that our technology directly impacts how a space mission is carried out. We were the first company in the world in 2019 to demonstrate in orbit deep learning algorithms on an Earth observation satellite. And now there are a few more companies that have done this, but we are ready to showcase another world first this year if things go well. So we will see later some details here. And we are not really just an R&D institution, we're also pushing technology in the commercial market. So we are now starting up our early adopter program for our technology. Of course, I don't expect anybody of you to be interested in trying it out. It's actually more related to companies, but feel free to give us your opinion about it. So let's touch a little bit on the vision that is really building the core idea behind Aiko. The vision for us is that we know that we are becoming a multiplanetary species. We know this because we have pretty crazy companies doing quite interesting stuff, both in the US and in Europe as well. It is a reality now that we will land on the moon again, and in maybe 10 years, we will go again on Mars. And our idea is to be there, providing our AI and automation capabilities for the companies that we will interact with in these very complex endeavors. This is our vision laid out. So we are trying to build this AI ecosystem to support not just spacecraft automation, which is the main business line that we let's say, we had since the foundation of the company in 2017. But also we will expand into other verticals that are astronaut support technology, lunar application and Martian applications, considering the automation of all the infrastructure we will have in this very distant worlds. So think about infrastructure monitoring, robotic applications for drones or rovers that might roam on the surface of those worlds as well. And this also taps into visual navigation techniques and similar technologies that are used to navigate to the moon and to Mars. As a vision, Aiko is becoming a leader in these technologies in space, and we want to build our heritage in space. But of course, through the years, we plan to expand our heritage also in other domains, particularly closely related to space, such as drones or stratospheric platforms, robotics, and this will be done by leveraging the IP, the intellectual property that we developed for space into other domains. Now, of course, we can zoom in if you want a little bit. I will be really quick on this part, but if we zoom in the spacecraft automation line, we are now pushing into the market, which is the library that is called Mirage. For us, this is our key product and the key, let's say, building block of our ecosystem. And the Mirage library is an automation library for single satellite now, and in the future for constellation automation, and in the future even more for terrestrial applications. As an automation library, Mirage itself works by using other deep learning applications, and Clarity and SAR processing here are examples of this. Clarity, for example, is our product for cloud detection in orbit that we flew already on a satellite. And we expect the list of applications to come in the future. So as you see, as I'm talking, I'm always referring to two things. It's either deep learning or automation technologies. And those are the foundation also of the conversation you will have later with the girls in Aiko. The same idea, we can push it for astronaut support technology and for visual navigation and deep space in general. So we plan in the upcoming years to release products into these two categories. So astronaut supports, and it could be station health monitoring or life support systems that are smart, but also in the future, AI that helps health monitoring of the astronauts, so of the people themselves that will live in these bases. But also for lunar and deep space, we're working on visual navigation technologies, automation of moon bases, and later on we will also work on AI for lunar citizens. Now let's really zoom in a little bit on the tech we are trying to build here. And if we think about very short-term problems, so the vision that you saw up to now was a very, very long-term vision. The short-term problems for us are quite related to spacecraft automation. And typically, we are trying to tackle two categories of problems. One is the problems on board the spacecraft. As you can see here, the first two images are related to Earth observation images that are acquired, or a situation that can be found in Earth observation satellites. And these missions have quite a problem. And the problem is the fact that they cannot understand, the satellites, I mean, they cannot really understand what's going on the data that they acquire. So the typical example is cloud detection. A satellite that does Earth observation is not able to understand that the photo it just acquired is completely covered by clouds. But as you can imagine, such an image is quite useless in the business perspective of the company that actually is operating the satellite. So nobody really wants to buy an image that is covered by clouds. Therefore, there is no need and there is no reason why the satellite should send this image to the ground. And this has a huge implication in terms of cost optimization, if we want, because the companies really pay a lot of money to get the satellite data down to Earth. So really optimizing and discarding this data on board is quite an achievement, and is promising to save quite a lot of money to these companies. This is a simple example. We can think of many more complex examples, of course. The second category is on the ground. So the third and the fourth images. Here we're really trying to have our artificial intelligence technology support operators on the ground in taking better decisions, or more timely, more speedier decisions, or supporting general infrastructure on ground to manage constellation missions that are of hundreds or thousands of satellites. So those are a couple of concepts we're working on at the moment. And as I told you before, Mirage for us is the main line that will enable many of these applications. So as I told you, we're building Mirage as a software library that will be installed in satellites and mission control centers, and will enable a state-of-art automation in these missions. Now, when I talk about automation, I'm referring to the state-of-art automation that has been, let's say, highlighted and defined for spacecraft operations. So it's not general automation, really trying to automate the typical operations that a spacecraft does. And over the time, you can see that we are planning to let Mirage grow in many different directions, really having Mirage as a key technology for all the automation activities we want to do on spacecrafts. So growing in the direction of capabilities for a new application like Earth observation, telecommunication, navigation, and so on. but also growing in the direction of hardware compatibility. So don't forget that we are an embedded AI company. So we are working very closely with hardware that are used by our customers in which, I mean, we need to install our software on. So it's something we need to consider quite closely. And also growing, of course, in the direction of user adoption. So we're talking about flying on small satellite mission. So small satellite, we're talking about CubeSat, nanosatellites, things that really weigh less than maybe 100, 200 kilos. And the goal for us in the long-term goal is also to fly on the very big missions, the Copernicus, the Galileo, the deep space probes, and so on. Now, really, a couple of slides on the company, and then I will give the word. When you think about Aiko, and also when you consider whether you should come, let's say, come work in Aiko, and we will talk about this opportunity later, you need to understand that we offer three key expertise to our partners. The first of all is the state-of-art AI. So in a world where spacecraft engineering is a slow activity, pushing AI into this domain is something that needs to take care of the fact that every 6 months we have a new algorithm that is coming out in the scene. And as a startup, our role is to make sure that our partner always gets the most advanced technology it can get from that is coming out from the research. So this is the first part. The second key expertise is, of course, going towards the embedded. So really pushing for the optimization and customization of these algorithms to fit on hardware resources that are quite constrained. CPUs, for example, are quite limited in space. Really think about the similarity with the mobile world, where you cannot still execute many of the algorithms that maybe you have running on your workstation. Well, space is even worse than that. So we are now seeing multi-core processors flying in space. So the situation is even worse. And as a key competence, we're trying to build this capability of optimization of AI algorithms for space. The third point we're investing on is, generally speaking, safety critical AI, but we can have a look at this as explainable AI, I would say. So really making sure that our customer, which by the way, doesn't really know much about AI, is able to pick our technology and is reassured that our technology will perform well under the strict requirements that the space mission design or implementation phase would ask to our technology. Explanation for us also is very critical because, of course, we need to be able to reassure the customer in this direction. Trying somehow really to change the idea that this is a 2010 idea that deep learning and AI are really a black box. We're trying to change this idea into something that we can explain. So here is a list of customers and contracts we have active at the moment. This is really to show you that Aiko is becoming a quite established European reality in AI and automation. As you can see from all these contracts, there is always either the word AI or automation. And we're working in different directions, whether it's telecommunication missions, Earth observation, constellation management missions, and so on. Also deep space, by the way. And of course, we look forward in the upcoming years for these contracts to grow in complexity and in number, of course. Now we can check briefly on where we will fly where we've flown and where we will fly in the upcoming years. Well, we started in 2019 with Satellogic. We've flown on this Earth observation mission, as I was telling you. And the plan is to fly this year with Spacety. This is a Chinese / Luxembourgish company that they are flying synthetic aperture radar satellite in orbit. And we are signing now an agreement with them to fly on their satellites. And next year is really looking pretty crazy. We have the GOMX-5 mission for technology validation in orbit. We're really planning to demonstrate the capabilities of our library. And 2 constellation missions, IE Express and the Space Data Gateway, will also fly next year. Now, the last point is really touching a little bit on the most important part of our company at the moment, which is and it will also be like that, which is the team. So as you can see, the team is super young. Actually, I'm the oldest one, so really, really younger than me, everybody, luckily. And extremely, extremely focused on deep tech innovation here. So it's either that we get engineering mindset from engineers that are coming from the automation or computer science department, let's put it this way, but also basic, let's say not basic, but also, let's say, more abstract backgrounds like physicists, astrophysicists, mathematicians that are quite excellent in providing us the background that we need also for more theoretical reasonings and so on. Then, of course, as all the companies, we have a business development team, and in general, we plan to have this company grow quite more in the future. And now, this is probably the last slide. So this is the end of my introduction. But I really want to say two things today. One is that we are really happy to have the first girls that we present today. And this is a message that we want to send as a company. Maybe this should be really done by everybody, but at least we want to give our part here. We really want to increase the ranks and the numbers of the girls working in Aiko in general. We think we should push for this equality and equity in the workplace. So if anybody from the participant wants to apply in any position in Aiko, feel free to send us your CV, and we will be super happy to consider it. And the second point is really a little bit more general. Consider at the moment the company size is more or less 16, 17 people, and we need to grow to 27 by the end of this year. So we will have 10 more additional positions to be filled up. And really, some of these positions will be deep learning engineers, data scientists, engineers for automation, and so on. The majority of them will be like this. So please go ahead and send us your CVs, because we will gladly take you on board. Now, this is it. Thanks for the opportunity. I think I will leave the word to I don't know who's starting among the four. And maybe, I don't know, if there is time for questions, you will let me know. Otherwise, we will do it at the end.
Yeah,
Okay.
maybe. Sorry,
go.
No, just I wanted to say that maybe for the questions, the right moment will be at the end of the event. Just this.
Sure, perfect.
Okay.
Go, Teme.
Okay, nice to meet you to everybody. I'm Temenuzhka Avramova, and I'm one of the girls working in Aiko. And now I will start sharing the screen, actually, and then I will leave the floor to my colleague Dilara.
Thank you, Teme.
Okay.
So for the forwarding the slides, Teme.
Can you, do you
No.
have the control?
No, it doesn't work. Yeah,
I
maybe
approve it.
you can go with it. It's okay for me. It doesn't work now. You can go. Thank you.
Okay.
I will start. I'm Dilara, deep learning engineer at Aiko. Really happy to be in this event today. So today I will just go with who I am and what I'm doing basically in the beginning. Then I will go with the, let's say, the beginning of our presentation in a light manner. Then my colleagues will explain maybe more in detail. So basically what I'm doing is like I take my degree in University of Southampton, Electronics and Computer Science Department. Then I continue with my PhD in Yıldız Technical University. Again, this is also Electronics and Communication Engineering, but I also cooperate with University of Milan, Computer Science Department for my PhD. For my master degree to my PhD, I start with machine learning, then I continue with deep learning. So basically, I spent over 6 years with machine learning based stuff, let's call it that way. So now I'm working in Aiko as a deep learning engineer, and I'm coming from academic background. So if you have any questions on these things, I will explain, and I will be glad to answer the questions. Actually, I choose the content for the next slide, Temel. I choose the content a little bit lighter than my colleagues, because I thought maybe it will be interesting for you to know, like, what we are doing in general context. Obviously, Lorenzo already explained it, but how is it being in a Aiko, like deep tech startup? What are the things that we will face on? And also a day for me, for example, as an AI engineer, deep learning engineer, what I'm doing. So what type of problems or the stuff I'm facing. And then a toolkit for AI. Sorry? And then a toolkit for an AI engineer. I'm sure that most of you are familiar with the concept, but just I want to go over it and discuss a little bit, just to be sure that no one is missing any point. So for this one. So what are we? Already Lorenzo explained deep tech AI startup. So basically we are facing different problems in space environment. And we are using the most, let's say, state-of-art AI-based algorithms into our problems and try to fix the problems with these things in space environment. So every day it's a new day for us to face new problems, because things doesn't work as in the paper, let's say. Theory is totally different than the practical approaches. We hope, for example, when we check a paper, research paper, we hope that, okay, this algorithm will work in time series, let's say, but when it comes to the truth, everything changed. So it's basically like problem solving every day, finding a solution and facing another new stuff. But it's quite, not to say, if you really like what you are doing, it's quite enjoyable journey, let's say. So, but it matters, I mean, being in a startup. So I would like to mention the first thing. Everyone matters, actually. Each person poses a huge impact. Today, I'm doing something for the future of the company. And my impact is because of the number of the persons and the probability and the potential of the Aiko. Everything that I do today, tomorrow, and the other day matters. So that's I think, the most important stuff being in a startup, let's say. And then the other stuff, fast growing environment, because every day we need to improve ourselves. We are facing new problems, we need to solve them, and then another ones. We need to learn many things because we are limited in person, and then we need to finish the stuff, today's works for tomorrow, to be, how to say, make the project or make the things working. So let's call it that way. And every day, as I said, real-world product developments. For example, Mirage in our case. Mirage is, as Lorenzo said, it will be available in the space, maybe in the 10 years, let's say, it will be in really good position all around the world. So what we are putting is like developing that real world product. It's not like in academia that we are only focusing on the theoretical perspective, but also the practical one. So this is quite good also being in a startup. And we are not publishing for the sake of the publishing. I'm 100% sure that you are familiar with the concept. When we check several, let's say, journals or magazines, we saw many papers. We are really, how to say, tired of which one we need to read, which one we need to follow. But obviously, if you ask an expert, most probably they will point out several papers instead of all of them. So it's like there are several papers that are worth to publish, and there are several papers because of the community pushing just for publishing, sake of publishing. There are many papers, maybe most of the time not that successful, let's say, in general context. So we are passing this part. Instead, we are publishing only what we are doing and what is really matters in the space environment, let's say. And then the last, let's say, pros, being in a startup, is the previous one, it's like every day, as I said, we are facing some problems, and we need to go out of our comfort zone and just try to learn something, do something from the beginning of any project to the end. When we look back to the point that we start, it's just personal improvement in the end of the day. So I think it's quite good point, because if you are young and if you are facing, let's say, because AI is a topic that is in the, how to say, in process, the development already in process. So that's why everyday improvement is quite good for us. And for the cons, if we will talk about the cons, let's say, it's a little bit tricky, actually. It seems like cons, but actually it's not cons. In the startup, as I said, we don't have many experts on, let's say, like very senior members, let's say they work on more than 20 years on something, only one specific topic. So we cannot get this type of information directly from someone else. Instead, we need to share information and think about it. So this type of stuff in mostly established companies, we don't have these things in a startup, but still, since we are a deep tech startup and we have huge potential to be big tech company, so I think this comfort maybe we don't have, but in the end, our company will be one of them, so we will have it. So that's the only cons, but still, I don't think it's totally cons. So I would like to explain that way. For the next one, I would like to go over the Thank you. Yes, this one. So I'm sure most of you are familiar with the concept because we are taking the general courses most probably, but I would like to just go over basic stuff. So what happens when we start a project? The data came, problem came. So what we do is, like, obviously not every problem is for our domain, let's say. So we need to extract some data, understand the data. Maybe data is messy. We need to fix several problems, and we need to also not fix the problems, let's say, not only the pre-processing. We need to do some sort of statistical analysis just to understand what type of data we are facing, just to think about what type of model I can use, or in the future, like the data is enough, or should I ask maybe more things, the questions, because we are dealing with also the how to say, different companies and the partners. If we don't ask in the beginning of the project, everything can be messy. So I just wanted to go over in a simple direction, let's say. When you receive the data wrangling, explanatory data analysis is important. I'm sure that you know these things, you are familiar with these things. What we do is, like, we just clean the data, as you know, getting rid of everything that has missing most of the time. And then before normalizing, let's say, we are checking the unique ones. And with unique ones, if we are talking about big data, it's not possible for us to go with the statistical analysis for all of the data in a limited time, let's say. So we are checking most of the unique, let's say, to have some sort of vibe to understand the data with statistical analysis. Then later, we understood our data. If there is a sparseness, if there is not sparseness, if data features are correlated to several areas, let's say, we try to go with the nonlinear models, let's say, or maybe if it's sparse-based models, let's say sparse autoencoders. After modeling things, after choosing the model, the standard procedure goes like training and the testing sets. Sometimes validation sets come too for the fine tuning, so on. And then choosing the right accuracy metric, which is quite important because most of the time data is not what we expected actually. Data comes several classes, let's say in a minority, not many samples on, let's say, so we need to choose accuracy metric, like not accuracy, but let's say confusion matrices, true, false, positive rate, so on. So I'm just mentioning these things just for you to not to miss anything, not to only focus on what is in there. Like we saw this accuracy metric, so we need to go with this now. According to problem, just try to be a little bit flexible and always think that the things that we learn in the theory not always directly applicable to the problem. So I really want to share these things. I know it's simple, but just a beginning, light beginning for our presentation, let's say. Obviously, there is another concept in here, which is relatively new, let's say. Since companies and companies who require for the project output and the companies who work on the project, they use, let's say, different models, but they are generally deep learning based. So they don't understand what's going on, why this model decide that way or this way. So nowadays, many companies are requiring some sort of explanation of the model, how they decide, why they decide that way. So in this point, explainable AI is also quite important, not only for AI engineer scientists, but also for directly data scientist perspective of view as well. There are plenty of methods. Most of them, their paper and their official codes are available. So I hope you can just after the presentation, you can go over it and, check a little bit. According to your problem, you can take them and use at the end of your model training and testing. So for the next slide, this will be the last slide of mine. I'm sorry for talking a little bit, long, maybe. I don't want to bore you. So for this one, so what we are using as a, what is the toolkit? I'm sure that many of you are familiar with SQL or not pandas, Python or C++ or I don't know, the other language, let's say. So most of the time what we do is like, as I told you in the first step, data explanatory part, what I do is like I tend to use pandas a lot because pandas has a lot of good perspectives for data handling stuff. And then obviously when you are handling the data, you need to some sort of extraction, understanding the data, yes, but you need to show also some sort of visual way, let's say. So you can use, generally I tend to use Seaborn and ggplot2, but I just give them for example for the Python users. You can go with what you are using as a main, let's say, software. You can go with the related libraries too. But I would like for you to be sure about these things. One thing. First, please check the libraries that is directly associated to data because there are new things are always coming up. People always develop new things over the libraries. I'm talking about pandas, for example. If you are sure how to use it, it makes really easier for your life because dealing with the data, and if you can manage it in a simple manner, let's say, it's really cool. I will give just one short example. Let's say you don't have GPU capacity and you have really big data and you just want to use this data and understand. In pandas, there are many opportunities. If your data is big, but your computer is not capable, let's say, you can still divide into chunks and just upload it and try to understand in chunks, like not in Mongo, but you just divide your, let's say, the input, and then try to observe some things. This type of maybe little stuff make your day easier. Otherwise, you will continue again, try to manage you will get memory errors on. So, and then I put PyTorch in here, but obviously, I mean, this is deep learning models based, let's say, library. You can use TensorFlow, you can use the other stuff too. These are also simple for you to implement your model. Otherwise, you need to write everything so on. So that's why I put one in here. And as a library, for visualizing library, I know there are many available also softwares for the other stuff, but for the integrated ones with Python, I really suggest 𝗔𝗕𝗎𝗄𝗏 and Seaborn, which are really used even in the big companies. They don't need to go over for different software, but they are staying in the still Python and focus on this. That's it. And then the other stuff, I will go, okay, I will answer the question after finishing this part, and then I will let my friends go, otherwise I will talk too much. What is another thing is a good math and statistics background. Why it's important? Because every day, if we are facing limited data, or we just have big data, but still the data that matters is in the end statistical perspective. Let's say we need to understand even simple terms like random variable, expectation, so on. So please, if you want to really good data scientists, go over statistical courses. I don't know, I'm sure you take it, but go over it. There are many websites also visualize the things, so you will be familiar with and you will enjoy. And then the other things, since the AI domain is fast and changing really fast manner, let's say, you need to really enjoy and then interested in the lifelong learning. This is a fact. Today I know something. If I don't read anything in 2 years, I know nothing. So please, even though the basic stuff are really important, let's say statistics, or let's say standard shallow machine learning models, to keep up with the content and the literature, you need to always go for the papers, the websites, everything, okay? And then the other stuff, since we are facing different domain stuff, even though it's space domain, even in the space domain, there are different problems. So sometimes domain knowledge is important. So as a data scientist, future data scientist, I'm talking about you now, I really recommend you to get the knowledge from different domains, which makes you really powerful. Why? Because you understand one model, how one model works on different domains, and maybe the thing that you think theoretically is not true in the practically. So I will really recommend you that always go out of your comfort zone. If you know one domain, let's say time domain, go over computer vision domain, just to try the method, let's say, to see more. And the other stuff, again, data is everything, but using data in a misleading way is also horrifying and really distracting, let's say, destructive stuff. So please be sure about overfitting, underfitting issues and how you can handle. There are not only one ways, there are different ways. I know many of you are familiar with one or a couple of ways maybe, but please go over all of them just to be sure that you are not missing anything, because this is quite important. Like data is everything. What you give to your model just try to train, sort of memorize, and then try to understand your data. But if you are missing something in the data or over-exaggerating several samples, too much giving the same sample, everything is a chaos. So, and the last way is like, please be sure about the evaluation metrics, which are quite important. As I mentioned before, like you need to understand where you will use accuracy, where you will use REOST, or where you will use confusion matrices or the other stuff. So please don't underestimate evaluation metrics. They are also a good, way to show that your model works, but in a true way. So thank you very much.
Just before, sorry, Dilara. Just before we forget it, there is a question on the chat, so it's better that we answer it as soon as possible, because otherwise I will forget it. That's the reason.
Okay. So the Python libraries in Aiko, we are using TensorFlow, Keras backend most of the time. But for example, for me, I was using PyTorch. Still, I'm using PyTorch. But in the company, we generally based on TensorFlow. And then what type of unstructured data do you deal with on a daily basis, like audio, text? Actually, depending on the projects, the last project was text actually. It was EGCE log file. So we basically use many regexes and just to check some features, extract some features from the text files. But obviously, the last project I'm working is computer vision, so they are images. Until now, I didn't work in audio samples in the company, but I think maybe in the next slides, my colleagues will explain more in detail about the inputs. That's it. I'm sorry that I talked too much. I didn't want it, but...
Okay. Yeah, guys, consider that working with satellite data, we are working basically with images or telemetry, which are time series. So this is it from the data part. So I can start. Okay, thank you. Hello, everyone. I'm Ilaria, and as Dilara, I'm a deep learning engineer at Aiko. And I'd say I made the AI domain with my master thesis at the University of Arizona, because here I worked on deep learning approach for autonomous lunar landing. And thanks to this study, I had the possibility to understand this beautiful domain and this wonderful domain. And after my graduation, I was searching for something that can link the space domain with the AI. And for this, I searched for Aiko, which is, as Lorenzo said, an high-tech company for AI technologies. And so I'm in Aiko since 2 years, more or less. So now I will present one of the projects that I'm working on. Okay. So now I'm working with, I can't change the slide. Okay. So now I'm working on the variational encoders that I think you know very well. And as you said, the state of the art of the variational encoders started from the data set that it's famous, let's say, MNIST data set. And the potential of the variational encoder is to generate new images, new features, starting from the latent space, because this type of neural network is able to learn the distribution of the data and map this in the latent space. So if you want to generate new samples that are statistical same to the original one, you can use this type of neural net. But a step forward of this type of neural net is the conditional variational autoencoders that is able to generate how to say the new samples, but by giving a condition in the input. So if concerning the MNIST data set, if I want to generate the sample of number one, I can push for this with an input, which says to the neural net to generate this type of sample. In Aiko, we are pushing for these technologies because we trust in the autoencoders. So now we are working on to push this type of technologies by using multiple labels in the input. So here you can see a project that I'm working on. So I have this type of images that are called Vutek maps, that are basically maps that are related to the electron content of the atmosphere that the satellite is able to measure. But this type of maps are strictly correlated to the solar data, which are the 𝗖𝗎𝗍, the solar flux, the day of the year, the hours of the day. And we want to understand if we can generate new samples by using the variational encoders and by pushing the technologies to use, instead of one labels to condition the samples, multiple labels as you can see here. And the results are pretty good up to now. This is a contract, so in the future we will deliver this type of technology to the ISA contractor. And this is a part of my study that I presented here. And I think this is my last slide. Yes, because now there is Federica. And if you have any question, I can answer. So probably at the end, I don't know. Fede, if you want, you can go, I think.
Okay, so can you hear me properly?
Yes, we can.
Yes.
Okay, perfect. So hello to everyone. I'm Federica, and I'm really happy to be here today, as I graduated last December at Politecnico di Milano, obtaining my master's degree in automation and control engineering. My background is therefore not exactly the one of a space engineer, and so it could be interesting to briefly explain why I am here today. I joined Aiko right after the end of my studies at the beginning of this year, and I've always been very curious about human mind and its outstanding capabilities, wondering how and how many of those abilities could have been reproduced. And as you can imagine, in this sense, for me, artificial intelligence was love at first sight. And after graduation, I wasn't able to call a name for the job of my dreams, but I was sure that I wanted to explore more and more the artificial intelligence field. And my interest was to do research, but not from a theoretical perspective. And because I wanted to know new technologies and apply them in innovative domains. Those are mainly the thoughts that led me to Aiko, which was not the most obvious choice because of my academic background. Working in the space domain is not a joke, as the problems encountered while working as an engineer on Earth become even more critical. But on the other hand, this means that challenges are really a matter of everyday life, especially when you are working in a team that, as Lorenzo said, aims to build an artificial intelligence ecosystem to support operations and space missions. To give a taste of what I'm talking about, I'd like to share with you the main project in which I'm currently involved. And okay, we are far from the time in which space was a mysterious and unreachable place. And actually, there is quite a populated space out there. And it will be even more crowded as the space economy is moving toward a so-called mega constellations era, with an increased number of satellites and of constellation sizes. This, of course, will cause a huge increase in the complexity of the constellation's features and operations needed to maintain them active and functioning. Even limiting our analysis to and considering only constellations that are now orbiting around our planet, and here, for example, we see the active Starlink satellites, it is clear how new challenges are posed. So new methods and technologies are needed to address the criticalities entailed by these space trends, because currently adopted approaches relies mainly on human-in-the-loop solutions that are not scalable. And so Aiko's objective is to demonstrate that artificial intelligence can be trusted also in such safety-critical issues. The need for automation is so urgent and can be applied considering two slightly different objectives. First of all, the operations related to the management of the constellations can be handled in an autonomous way, providing the satellites with the ability necessary to maintain their mutual arrangement and so to autonomously perform the so-called station keeping operations, while avoiding also possible obstacles thanks to collision avoidance capabilities, and equipping them with the ability of changing their formation so as to satisfy new requirements. The proposal of innovative and reliable methods to autonomously manage constellations will pave the road also towards the so-called cooperative constellations. That is the goal, the main goal of our project. In fact, in a scenario with increasing complexity, satellite won't be anymore single entities that need to interact separately one with another, but rather constellation will act as multi-agent intelligence systems, where each single agent will be able to cooperate with the others to pursue global shared goals. And the constellation will be also able to handle failures due to unavailability of single satellites or maybe their inability to perform some tasks, thanks to effective communication protocols and replanning strategies. So, summing up, the path towards cooperative constellation, that is the goal of our current project on constellations, and will become also the starting point of further research to exploit even more artificial intelligence in such innovative and safety critical issues. Well, this path takes shape equipping satellite constellations with abilities to autonomously manage themselves, and then building on those abilities also the communication, coordination, and cooperation strategies that we desire. And all these features to enable autonomous constellation management and cooperative constellations are planned to be integrated inside the Mirage automation library, together with the already implemented single satellites functionalities, so as to enable fully autonomous space missions. And with this, I really thank you for the attention, and I hope you are enjoying this event, and I leave the floor to Teme if there are no questions so far.
Okay, hi again, I'm Temenuzhka Avramova, and I studied mathematical engineering at Politecnico di Milano. And in particular, I did scientific computing. The reason why I ended up there is because I have always had a great interest for mathematics in general, for apply mathematics application. Almost 1 year ago, I got to know Aiko, and since July, I am a part of the team of Aiko. And now I'm working in the automation section, and I'm specializing myself in algorithms and optimization for autonomous space missions. Today, what I want to show you today is just, let's say, just example of how can mathematics be applied in space, and in general, what we face almost every day in Aiko. This example comes from a project called Space Data Gateway, and it's a project that Aiko does in a consortium with other companies. And the main aim of the project is to improve the communication in terms of time and volume capacity between satellites that are nanosat, located in the LEO orbit, and the communication between these satellites and ground station. The main idea how we can do it is to enable each satellite not to be only the final node that receives and transmits its messages, but also as a node that forwards messages from other nodes to others. So then a group of satellites can make a communication net, incrementing so the spread of messages inside this net. So we can represent this net as with the graph theory as a graph where the vertices are the communication entities. They can be satellites or ground station, and the edges represent the communication visibility between two communication entities. For example, in this case, we see that vertex 1 can communicate with vertex 2, and vertex 2 can communicate with vertex 3 because they are in this, they have visibility, while vertex 1 cannot do it with vertex 3. Since these objects are moving because of the satellite trajectory, or for the ground station because of the Earth rotation, we understand how we actually to analyze a communication net of the for these objects, we will need more than one graph in time. So we will have more graphs for each time, with, of course, with the same vertices, but with different edges, because the communication windows change in time. So another thing that we have to consider is that for a technical reason, we consider that each vertex, each satellite can communicate with another one, with only another one at a time. That means that even if it's possible to have more communication, for example, V2 to communicate with V1 or V3 at the same time, it's possible, but it will have to choose only one of them. So we end up what we can call in graph theory matching problem. And this is an example of how it can be solved. For example, we have the same starting graph, but then we have two different matchings that doesn't violate the assumption of maximum one communication, but they are different. And we can understand, for example, that the one with more matches is the one in which we are interested more, because we optimize the number of matches for graph. So we are starting to speak about maximum cardinality matching. But we have to remember also another thing, because we are not having only one graph, but we have many graphs in time. And is it enough for us just trying to obtain for each graph a maximum cardinality matching? Actually not, because let's imagine this case in which we have a graph at time t and another graph to the time immediately after, time I plus 1, in which we change only the visibility of vertex 5. All the rest is the same. So our algorithm of maximum cardinality matching, we will solve again this problem more or less in the same time. But actually, we would be happy to enable always the same edges. So what we want to do actually is to give more priority also to edges that were not enabled in the previous steps. So the idea is to give to every edge a weight that is indirectly proportional to how often that edge, that communication was enabled, in order to give a priority to the edges that were less often called, and again to keep track of the aim to have as much as possible communication edges activated. So here we end up to the last version of the algorithm that we found in literature and that we applied, that is the maximum weighted matching. And here there is a result. This is a simulation with a few satellites, and you can see how, of course, during the movement of that objects, the graphs are always different because of the position. And what we see with the white lines are the possible communication edges, and the red one are the communications enabled with the maximum weighted matching problem. So okay, so just a graph to show what we obtained with the application of this algorithm in what we achieved. Here we have the disposition of the communication windows on a simulation with 10 satellites and 1 ground station, that is 𝗙𝗖𝗎𝗪𝗔𝗕𝗎𝗓, and everything is done in a time of 2 weeks. The red bars actually indicates the classical communication, that it's the communication, the possibility for the test Sat9 to communicate with the ground station only when it's directly in the Windows visibility of the ground station. While if we are while in the blue, we can see how much we improve the communication windows if we accept to have a latency, for example, less than 15 minutes, and we accept to spread the messages on our network. And we see how increasing also the latency, we have more and more windows. This, of course, the benefit of this is first that we can be more reactive, because instead of waiting for hours, we can just wait 15, 30 or half an hour. And also having bigger windows of communication means also that we can send a bigger volume of data. And so this is the easy way to see how we improve just with the algorithm. And I want to conclude saying that this was only an example of what we face every day in many projects, both automation and deep learning team. And I think on my side, one exciting thing is that new mathematical implication and in general, new technologies, new, let's say, new challenges comes every day. So this is something that really excites me. And this is on my side. So now it's question time.
Thanks, Teme. So maybe in the meanwhile that we get additional question, I think we can answer on the question that was here on the type of customers we interact with. So in Aiko, we are working really in two different directions. One is the institutional markets, and by institutions we mean the European and Italian space agencies. And in general, all the contracts that are fueled by one of these two space agencies. The other direction is the commercial action, and the commercial direction where we sell our technology to private companies at the moment in European domain, but we're also looking to expand into the US in the upcoming times. The last point is that as categories of customers, we sell to mainly two types of customers. One is the spacecraft manufacturers. So companies like, I don't know, Thales Alenia Space, Tyvak, and so on, that are producing the satellites themselves. So we integrate our technology in their offering. And the second direction is the satellite operators, which is constituted by all the companies that buy satellite and operate the satellite to deliver a service to third-party users. Hope that will answer the question. So now we are having a look at some question concerning careers in general. So yes, we are considering thesis internships absolutely as well. Feel free to send an email at careers@aicospace.com. So maybe I will send the link here below. And concerning applying for a job, send the CV and really short motivation letter if you really want to, but the CV should be sufficient for us to contact you back. And the last one is actually a technical question, maybe related to Teme, so feel free to answer that one, Teme. Yeah.
Yes, I see. the maximum latency, actually, I don't know. I mean, up to now, we are considering things around half an hour, latency of half an hour. Also because consider that satellites can have more or less they do the orbit, since they are in LEO orbits. They finish their orbit in 1 hour, 1 hour and a half, 2 hours. So every, let's say, 2 hours, they are visible to the ground station.
Yeah, here maybe just saying that by latency, we don't mean the time in which our onboard algorithm runs. So yeah, it runs much quicker, but we're considering half an hour in the program we're solving. Yeah. And how do we deal with the deployment of deep learning algorithms on resource-constrained satellites? Well, we mainly do that by 2 things. First, interacting with the customer, really making sure we get the list of requirements and their computational capabilities that are available. And the second direction is of course, optimization. So when we build a model, especially a deep learning model in this case, the team works in developing a model that is optimized and maybe using a limited number of parameters, so that the architectures and so on, the solution we pick are quite different with respect to what you would do if you would implement that model on a workstation for a ground-related application. Or they might be the same, it really depends on the cases. But we put an extra attention in making sure our models are quite thin in the numbers of parameters, so therefore occupying less space on the satellite.
Maybe there is a question that you didn't see, which is from Paolo.
Oh yeah, the data storage on board. So, well, the environment is really changing. Now we have satellites that are even let's say cheap satellites that can host probably tens, if not hundreds of gigabytes on board, the cheap ones. Well, of course, we're talking about the expensive ones. We go into the tera domain. But an interesting aspect here is actually the major limitation for the model size is also the constraint on uploading the model to space. So it's not really the biggest constraint is not really making sure that the models can be stored on board, but actually that it can be sent on board with the limited connection time that you get when the satellite is above your sorry, when it's above your station. So this is another important limitation that we are dealing with.
Okay, so okay, another question.
R&D, yeah, I mean, Aiko is all about R&D. Really, we have internal R&D lines, which is mainly Mirage and all the applications enabling autonomous operations in space, and the external R&D lines, which are mainly the institutional contracts. So contracts with the European Space Agency, like visual navigation, Earth observation, well, deep learning for Earth observation, constellation management, and so on, and also the Italian Space Agencies as well. So touching on the last question that we received concerning the standards and in general the things that we do to make sure that you fly safely in space. Yeah, it is actually quite different. So it's there are so many different aspects with respect to deploying in production a model on the ground, they range from reliability aspect, as you suggest. For example, how does a model perform when you have radiation effects in orbit? That is something that we investigated as well. What happens if you get radiation effect that flips the bytes of your memory, for example, and then suddenly your neural network has weights that are changing due to these radiation effects. Now, this is our first things that we are considering, of course, and there are many more depending on the problem caused by this radiation effect. But also there are other things, maybe safety things that to be considered depending on the fact that the deep learning model, for example, or the automation algorithm needs to do something that is called safety critical, for example, controlling the attitude or controlling where the satellite is going. And those things require quite even more, let's say, testing and validation techniques on the ground. So while generally speaking, maybe the model is quite comparable, apart from the optimization itself, is what is deploying the model into the specific environment, in this case, a satellite, that really changes the engineering aspects. And explainability application, yeah, we can name a few for sure. For first, the one that we did in this contract that Ilaria presented, the 𝗤𝗎𝗏𝗏 map generation. There, we explored Shapley value analysis, for example, to understand the impact of the data set and the model on explaining how the model was taking decision. But also there are maybe, but then I can leave the word to Ilaria and Dilara to present all the explainability techniques that they are there, because that is technical stuff and they know way more than me. But yeah, generally speaking, yeah, that is something. And then maybe, I don't know, Dilara, if you want to touch on some deep learning explainability things that we are, I don't know, with maps or things like that.
Oh, Ila.
Yogi?
Yeah. For now, we are, as Lorenzo said, as a practical example, we have the shape analysis, because in this project we have, for example, 5 temperature as input to be related to 5 emissivity measurements coming from the satellites, and from ESA side they use analytical method to pass from one to the other, and we are using instead a neural network, and they want to understand if the neural network link the input to the output as the same way as the analytical method, let's say. In doing this, we are using the shape values to understand how the neural network works. And we are finding slightly different results from what the analytical method does, let's say. So it is really interesting, and it is a research field on our side, because we have to trust the model and try to explain to the customer why the models are taking some decision. On the other side, there are a lot of graphical, let's say, method like heat maps or correlation maps, probably, and we use both of these. I don't know, Dilara, if you want to add something.
I mean, no. So it's a research field, and in any case, the analytic models are based on the experience of that specific domain expert, let's say. So they base on, let's say, the previous samples stuck on several, let's say, features, and they calculate accordingly. But in the data itself, maybe internally, the things that we didn't see, neural networks can manage it to check, to understand the data. So, I mean, explainable AI is a good way to show what's going on in there. So I don't have that many addition, but this field is quite promising. So there are many methods we are now exploring, not only the SHAP, but also 𝗎𝗎𝗎 and the other methods too. So we are also planning to use them not only for one type of data, because different explainable AI methods can be applicable, let's say, for different input data. Several of them based on image data, let's say, several of them only designed for categorical data. So in this perspective, it's quite a good R&D topic anyway.
Oh, okay, maybe there are not any questions anymore. So yes, I think we can close. I would like to really thank you all the Aiko representatives that have done this amazing event, and I would like also thanks all the participants. And yes, I think we can, unless all of you have something to add, we can close the event now.
No, thank you guys for the opportunity. Again, reach out to us, follow us on the social media pages. There will be quite some news in the upcoming months and also new positions, so feel free to apply. And looking forward to meet you guys.
Okay, thank you. Okay, there is another question before we go. Where should I send?
Yeah, as I said, there is the email address just above your question. It's careers@icospace.com. Feel free to send the CV there, and or wait for an opening of a specific position on LinkedIn.
Okay.
All right. Bye, guys.
Okay.
Thanks
Thank you.
Thank you.
Really, thank you.
Bye-bye.
Bye. Bye.
Thank you guys. Bye.